So this is a short video on how to use TMS 320F28335 microcontroller along with its ADC port in order to generate a DQ frame using only the real voltage signal. So how do we start is that we're gonna make use of the ADC block over here, and we are going to make use of module A. Conversion mode is sequential. Right now we are making use of the software conversion only with a sample time of 0.001. Now make sure that the data type is unsigned integers of 16-bit. After that, what happens is that we have to make use of the bitwise and block, and after that we have to make use of a conversion block along with some of the gains over here to make sure that the output of real signal based on the maximum voltage at 3 volts comes out to be around 169 volts for the D frame. Okay, so what happens now is that the voltage signal coming from VR goes into this MVC real and imaginary block. Now this is one of the strategies that we have implemented in one of our papers. This makes use of two filters, one for each the current and for the voltage, and it makes sure that whatever real signal is being fed in, and the imaginary signal which comes out of this block is a 90 degrees phase shifted signal as compared to the real signal. Now both the VR and VI are used in the phase lock loop over here. This phase lock loop, as you can see inside, consists of a closed loop PI control based phase lock system. Now make sure that you understand that by implementing this program onto the microcontroller, you do not have a reference time, so you cannot make use of a integral block over here, either a discrete time integral or a continuous time integral over here, because you do not have any frame of reference for the time. So what I did over here is that I generated my own sine and cosine signals, which are similar to sine theta and cosine theta, which you can use once you go into the alpha beta to DQ frame. So this discrete time VCO, you can actually change this in such a way that it wraps around its own cycle after its own cycle is completed, and once that is done, you can actually get your sine theta and cosine theta through this way. Now make sure that for the sine wave generation, the initial phase is kept at -π/2, and for the cosine it's kept at 0. Alright, so once this is done, you can actually generate your own VD and VQ by making use of a simple DQ frame transformation. Once you have sine and cosine signals over here, you can make use of the transformation matrix in order to generate your VD and VQ. Now the question is that how can you see your DQ frame? One method is actually can be easily be performed by getting the internal values of the registers in Code Studio, or you can actually record the data by making use of SCI transmission block. But you can also make use of the GPIO digital output pins by comparing your values with an appropriate constant block. Now in this case, we expect that VD has to be less than or equal to 170, because we are giving a maximum voltage VR over here, which is 3 volts to the ADC pin. So that corresponds to like 120 volts 20 volts RMS, which must have a VD of 169.667. So if we compare with this 170, this should give a digital one at the output pin. Same goes with the VQ also. So now how we have done this practically is that over here we have got DC power supply. Now in order to have this regulated at 0 and 3 volts, we have rigged up a small circuit over here which is consisting of some capacitors and resistors which actually act as a voltage divider. Now the sine wave that we are giving through the sinusoidal through a function generator, and as you can see the frequency is set as 60 Hertz, and the amplitude can be set over here to the last knob. Now this is connected, the ADC is connected over here, so you can see that the ADC pin is connected to the A2 pin as we have seen in our Simulink block. We are looking at the digital output pins of 60 and 61. The 61 pin over here shows the VD, and as you can see over here, this gives you a digital output of 1, meaning that the value of the VD is less than or equal to 1.